Example 4 on series parallel pipes and minor losses. The flow rate through the pipe system shown is 0.85 cubic meter per second. The length of pipes 1, 2, 3, 4, and 5 are 1000 meters, 500 meters, 600 meters, 800 meters, and 700 meters respectively. Pipes 2, 3, and 4 are laid in parallel drawn from pipe 1 and discharges into pipe 5. The diameter of pipes 1, 2, 3, and 5 are 900 mm, 500 mm, 400 mm, and 750 mm respectively. So the diameter of pipe 4 is unknown. The total head loss in the system is 10 meters and friction factor is 0.02 for all pipes. Determine the discharge of pipe 2, the discharge of pipe 3, and the diameter cm of pipe 4. So we are asked to compute for the discharge in pipe 2, the discharge in pipe 3, and the diameter of pipe 4. So since the total head loss is given 10, it is equal to HF1, which we can compute, and plus HF2 plus HF5. Take note that 2, 3, and 4 are parallel, so HF2 equals HF3 equals HF4. Knowing head loss in pipe 1 and pipe 5, because the discharge is 0.85 through them, then substitute into the total head loss 10 equals HF1 plus HF2 plus HF5, then we can compute HF2. Knowing HF2, we can compute the discharge of pipe 2. Then, knowing the head loss in pipe 2, which is equal to head loss in pipe 3, then we can compute Q3. Then finally, Q1, which is 0.85, equals Q2, which we can solve, plus Q3, which we can solve also, plus Q4, which is unknown. So we can compute Q4. Knowing Q4, we can now compute the diameter of pipe 4. So that's the flow of the solution. So first, head loss total equals HF1 plus HF2 plus HF5. We can compute HF1. It is equal to 0.0826, friction factor 0.02, length of pipe 1, 1000, then Q1 0.85 square divided by diameter of pipe 1, 0.9 raised to 5. So HF1 is 0.0826, 0.02 times length 1000, discharge 0.85 square over diameter 0.9 raised to 5. So HF1 is 2.021 meters. We can also compute HF5 because the discharge is also 0.85. So HF5 is 0.0826, 0.02. Length of pipe 5 is 700. Discharge 0.85 square. Diameter of pipe 5 0.75 raised to 5. So it is equal to 3.521 meters. Substitute here where head loss total is 10. 10 equals 2.021 plus HF2 plus 3.521. So HF2 is 4.458 meters. Then equate it to head loss for HF2, 0.0826, 0.02 length of pipe 2, 500 Q2 square over diameter of pipe 2, 0.5. So 0.0826, 0.02, 500 Q2 square over 0.5 raised to 5 equals 4.458. So only Q2 is unknown here. 4.458 times 0.5 to the fifth divided by quantity 0.0826 times 0.02 times 5,000 and extract the square root. So Q2 is 0.4107 cubic meter per second. Since HF2 equals HF3, so 4.458 equals 0.0826, 0.02 times length of pipe 3, 600 Q3 square divided by diameter of pipe 3, 0.4 raised to 5. So 4.458 equals 0.0826, 0.02 times 600 Q3 square over 0.4 raised to 5. So Q3 is the unknown here. Square root of 4.458 times 0.45 to the 5th divided by quantity 0.0826 times 0.02 times 600. So Q3 is 0.2146 cubic meter per second. Then finally, diameter pi 4. Before we can compute the diameter pi 4, we need to solve for Q4. So 0.85 equals Q2 plus Q3 plus Q4. So HF2 is also equal to HF4. So 0.85 equals Q2 plus Q3 plus Q4. So Q4 is 0.2247 cubic meter per second. So the head loss is 4.458 equals 0.0826. 0.02, the length of pi 4 is 800. Then discharge of pi 4, 0.2247 square over diameter of pi 4 raised to 5. So diameter pi 4 is quantity 0.0826 times 0.02 times 800 times 0.2247 square divided by 4.458. Then everything should be raised to 1/5. So diameter pi 4 is 0.4316 meter, or in cm 43.16 cm divided by 100 times 100, sorry. So that's it for this problem.